So as I said, we will be just starting with some problems in areas. Okay? So some problems, or rather puzzles, problems in area calculation. Okay. I have a theme in mind. What is the way we are going to find these areas? But I just present the problems because there will be several ways. Okay. So let's start with the most basic question in this topic. Okay. Let's start with this. This can be. So we have this simple triangle, and we obviously know what the area of this, the formula of the area is in terms of heights and base. But since we are doing it from a problem solving perspective, I'm not going into the derivation and the concepts and so on in that sense. But what I want to ask is something related. Let's say I just draw a line like this. And I don't know much about the line, let's say. Let's say that the endpoints are A, B, and C here, and D. Now I don't know much. I only know that AD is 1/3 of DC. Okay? So AD is 1/3 of DC. So it's 1/4 of the whole thing. I only know this, and I know that area. So this you can say maybe problem 1. Know that area of ABC, let's say the whole triangle, is, you can take it to be 1. Yeah. So obviously the question is find area ABD. And this I expect to be easy, but I will see because I've not discussed geometry with any one of you. Okay. So no lengths or anything are given. It is 1/4, you're saying. Okay. So can you give a reason? Height is yeah, half into h into x. Yeah, that thing is 1, right? Right. And then from here you can calculate it. This is 1. And so from here you can get that this is 1/4. Okay. So Unab, is this okay for you also? This okay. This is a very basic property which you may have even seen as a theorem, right? So basically, what do we learn from here? A simple problem. We basically are learning that if there are two figures with the same base, with the same platform as the base. I mean, the same line as the base. Line segments are different, but the same base in that sense. Okay. So, and if they have a common height, okay, kind of understand, then the ratio of the areas is the ratio of the bases of the base lengths, right? So the ratio of ABD, and this, it's a very simple thing, but it will be applied in very crafty ways, okay, in more interesting problems. So we'll see ABD and this is DBC. Okay, this ratio will be the same as the ratio of the base, and should be absolutely clear. And you can see it from formula, or you can just see it from basic logic. So if the height is same, then the base is what determines the area. So you see, we are calculating, this is the first technique in calculating area, and we're basically using scaling, right? We're basically seeing how the area scales, how it scales when you change the length when you scale the length. So we're seeing one kind of scaling. We will see others, but let's move to the second problem. This was an absolutely basic question. So yeah, this is nowhere like an Olympiad level question or anything. Yeah. So, let's move to problem number 2. So just only doing problems. So the problem number 2 that I have in mind is we can try this problem. Some problems I've thought, so let's see which way we have to go. So here we just have a rectangle, and let's say I draw some lines like this, and let's say we make another line like this. Okay. So now even the ratios are not given. So we'll see A, B, C, D, E, just labeling them F. Okay. So the question is, if area of ABF is equal to 1, okay, and then I'll just say find area of DFE. So nothing else is given really, and E is also not given. So let's think. This is the big part. Okay. Any ideas? Did you guys get started? No. Okay. So suppose any ideas? Um, okay. All right. Now let's just think from the perspective of getting an answer. Suppose this was an MCQ. Nothing is given about E. Okay. I'm not writing this, but suppose if this was an MCQ and the answer was a number, then how would you find the answer for me or for yourself? If this is just an MCQ, how would you find the answer? Like you just need to know the answer. You don't care about the method. And nothing is given about E. Remember that. Apply, but how would you apply the options? That is the thing. Okay, let's say I gave you the options. Okay, so let's say the options was 1 was an option, and what does it look like? I can say 1.5, I can 2, and maybe 1.2. Right? So just give you the options. Okay, I mean I meant that if you have to just find if you just give an answer without a proof, then how would you give? But yeah, let's say the options are given. So in the geometry questions, what is the strategy to get the answer? Obviously, you could try to guess the measurement. That is one way. But okay, let's see. Nothing is given about E. E is random, arbitrary. Okay, come on, make a guess then. Let's see if you have 30 seconds to make a guess. Just for the answer's sake. Okay, 1.2. Based on what? Can you give a small reasoning if you have any? Okay, okay. So that's your reason. Unav, you have a guess? 1.2. Okay, okay. So you guys have not, you're not seeing an important thing here, that nothing is given about E. See, if it's a subjective question, that nothing is given about E can actually make the question difficult. But in an objective question, it doesn't make the question difficult. It makes the question easier in some sense. Just take a special E and find the answer. Do it. Take a special E. Then you'll get a sure answer. I mean, take E to a special point, because I mean, you are being told that the answer does not depend on E. Right. That is what the question is trying to tell you, right? That the answer does not depend on E. See? So can they be equal? They can be equal. So why do you think so? So you didn't first say that thing completely, then you say it's wrong or not. Say the thing again. It seems correct. So first you should complete it and then just see if it's logically correct. Hmm. Hmm. Yes. Yes. A B E. Right. D B E. Right. Right. And they have the same area. Right. Hence they have the same area. That's perfect. Yeah. Yes, right. So then you remove the common part and then you get this. So it's logically correct. So you should be confident. That's correct. Yeah. Yeah. I mean, if it's logically correct, it is correct. This is maths, right? If you say it and then check it again logically, or obviously check it from a different angle or ask someone, then you will understand. But logically, if it makes sense, it should be correct. So it is correct. And this is a very beautiful argument in some sense. I mean, I was trying to cheat a little bit, taking E to be a special point, so, but you've done it directly. So Ishana, do you see the logic? Yeah. And this is a very wonderful thing. He basically, the idea is to complete the picture, right? To complete the picture and find a commonality. So you have these two pink and orange triangles. The missing part is this thing, right? This thing. So that is what you have to complete. And once you complete, then it's just clear. I don't even need to say anything at all. Okay. So this is the technique, and this is known in the literature as what is known as the carpet technique. Okay, so it's sort of like there are two carpets, this ABE and DBE. They are like carpets and they're overlapping. Okay, so when you see the two carpets, you know that they are the same. That's clear. We did that in the last question, and we know it's true. Right? And then they are overlapping, and so you remove the overlapping part. But it's just the thing that you try to complete the picture. That is the thing, complete the picture. And yeah, so this is yeah, this is thing. So complete the picture. Complete the picture, and this is also known as a carpet technique. Maybe if you Google, you will find many other problems with this topic. I will discuss a few of them that I know of, and you will see. But obviously, I mean, there is no such thing as, it's like it. I mean, it's just logic. Yeah, yeah. But it's okay, right. So now you see, but what I was like, this is a very good solution, and it's nice. But suppose you don't spot it. Now you've seen it. Now you cannot unspot it. It's just there. It's so beautiful. It's hard to forget this. But I'm just saying, like, if this, like, in general, if you have geometry questions and if the answer does not depend, then you can take E to be a special point. And what is the special point that you should choose? You can take E to be the midpoint and do the calculations. Or even better, take E equal to what should be the special point? Just take it to be C, right? That's a good special point, right? It's not like it doesn't make it trivial, right? It is still there. And that's a good thing to take, right? So this is the kind of things you have to do in geometry, whether it's lens and so on. You have to know what to prove, you have to take special points. And if you don't have to prove, then you get the answer. So if you take to be E, then the region becomes, then it just gets split into two equal parts, right? This is, then this becomes what we want to find, which is obviously equal. Then the pink part will become this whole thing, right? It'll just spread like this. And then it's obviously equal. And even if you take this to the other end, which might be a little confusing, then you will see that both become zero. Right? So I'll just show you, though you can imagine it. But if you take it to the other end, so if this is a B, and if this is also your E, but that can confuse you a little bit. That can be a bit confusing. Okay, but it's true that if you take it like that, then F also comes here, right? Okay, make sure that you actually feel it, you agree with it. Okay, F also comes, moves, and it goes to B. When E goes to B, you can just see it. Then AFB becomes zero, right? AFB, in that case, it becomes zero. And then you see that DFE, because F and E are same, that also is zero. So you will see in all situations it is the same. So these limiting cases, special points, these are the way to go. Okay, these are the way to go, because if something happens in extreme cases, especially when that both the extreme cases, then it better be always true, apparently, seems like, right? Uh, just on some level, yeah, we can make all that more rigorous when we have more language, but these are some small tricks. but we also learned a very nice technique. Okay, let's move to problem number 3. So that's, let's see. First, let me write the problem. So this problem is also from some old, some old very junior Olympiad, I think Russian something. But yeah, now this problem is like a little interesting. RMO type, pre-RMO type, you could say. But I had seen this in some old RMO also. Similar question. Numbers may obviously change. So earlier problem, and you can make these questions yourself and just try to solve. Just obviously just don't do something very strange. Just like a natural extension. So I've just basically let's keep this line to be the exact same thing. This is problem number 3. And then I'm just saying that if you just take this line to be some other line, right? Then you know what you can ask. You can ask the area of these pieces in terms of the area of the bigger one, right? So let me just write the question. ABC, D, A, F. Okay. And let's say that BD by DC is 1/3. And let's say that AF by FC is 2/3. Okay, and maybe that doesn't look completely correct. Let me make this 1/4. That looks more correct. Okay, so, and also you can take that ABC is 1, or otherwise you can find the ratio with ABC. But yeah, let's just take it to be 1. And now you can ask yourself to find the area of any piece. It's just up to you. But let me just ask this and BED. Find. Let's see. Now this also, for the sake of finding for the sake of finding the answer, you can take this to be an equilateral triangle and do the question. Okay, obviously it may not make the problem simpler, but that's something that you can do, or take it to be a right triangle or something. So the way to specialize here, but we will not do this now. You can try this for homework and see if it makes the problem simpler. Because if you have to just find the answer, then you don't have to solve this problem for this thing, right? So yeah, I just say take a special, here we can specialize on the triangle, right? So we are simultaneously learning these things. Okay, so take a special triangle. But just you can note this down and try this for homework like this. But right now we'll just do it for general, because these cheap tricks you can try them. No. So in this case, we cannot take a special shift because all the shifts are given, kind of, right? But in this case, we can take the special shape. We can change the shape to be to a special one. Is that right? Okay, I mean, what I'm saying is you can assume ABC is equilateral and then try the problem. You see, because the answer should be the same, right? If the answer does not depend on the triangle, see, the answer is not depending on the triangle ABC. If there is an answer to this question, if there is a, answer, is there's a constant answer, right? Then it doesn't depend on the triangle ABC, like whether it's scaling or obtuse or whatever, right? So, okay, if it doesn't depend on the exact triangle, then I can assume my triangle is equilateral and do it. Is that right? Okay. So you can't change the shifts because the shifts are given, but you can take it to be an equilateral triangle because if the answer is that's not rigorous because that doesn't prove that the answer is constant and so on, but it gives you an answer. So okay, so this you can try for homework if taking an equilateral triangle helps because it may help, right? Because equilateral triangle is much easier understood. So that's what I mean. You can't change the shifts because if you change the shifts, then the answer changes. Right? Yeah. Okay. But here we'll just try it. We'll just do this normally first. You can try that. So there was only one line in the first problem. In the third problem, there are two lines. That's the only difference. Now, there are theorems to do these problems. We will try to see them later. You can use some intuition from physics like balancing, and you can take this to be the fulcrum and balance, and you can balance here, then the triangle is balanced. You can, those some things are there by putting weights and so on, but those techniques we will see a little later. Right now, we just do with very simple things. Area is a physical quantity, right? All the intuition comes from physical things. Obviously, we formalize it in maths and it maybe becomes a cleaner intuition or it becomes a theorem or it becomes an axiom sometimes. Okay. If you can't prove it. But it's a physical thing. So you should feel free to just use your imagination. That's so any ideas? Did anyone find the area of any piece? You can any of the four pieces you can find and see. I will just note down a few simple things. ABD, at least we know this is just this 1/5. These things we know. Yeah. Yes, this is doesn't look correct, right? 2/3. That's not correct. It should be 3/2. 2/3 just doesn't look correct. So I'm just finding the area of the big pieces, which you guys also can find. But yeah, whether it's useful or not, that you have to. So BED, which you are interested in, you can see it as a part of BFC. You can also see it as a part of ABD. So yeah, you can think. So BED is the common part. So any ideas? Hmm. Okay, we can. So can you give a reason as to why that will not give the wrong answer? Why that will give the right answer? Yes, no. So I can understand that taking the perpendicular will simplify the problem. So let me write here. Uh, assume that BF. So this is what you're saying. You're trying to assume this. Now I understand that assuming this will simplify the problem, but the question is, is it possible that this will affect the answer? Can this affect the answer? Just from the perspective of finding the answer, at least I'm asking. Rigorously speaking, obviously this is not correct to do. It's a wrong thing to do. But even from the perspective of finding the answer, is it a correct thing to do or not? Can so then you have to reason, because like what I was saying in the other kind of specialization where you have to take equilateral triangle, that does not change the answer, right? That does not change the answer, right? Because it's true for all triangles, the answer should come true for all triangles, because such ratios can be, you can, for any triangle, you can make such things. But will this affect the answer? Let's see. Actually, it will not affect. Let's think. This is a subtle things which will help you to gain more intuition about areas. Can this affect the answer? So, I mean, what does this question mean? Can this affect the answer? Yep. See, if you just compare this with the equilateral triangle thing, why does assuming, let me write this clearly, okay? Why does assuming ABC to be equilateral not affect the answer? Let's think this clearly, because this is simpler to answer. Then we'll try to answer that also. Or maybe you are right, it might affect. I have to think. Let's see. Let's see. No, it will not affect the answer. But let's first think about the equilateral triangle thing. Let's have a clear reason for this. Like not just, okay, it seems like it will not affect, so I'll take. That's fine. But if you know this clearly, then it will help you to form your own assumptions like this with confidence. Yes, right. So because the question can be posed for an equilateral triangle. Yeah, right. So what you said is the exact thing I'm saying. So let's just see it like here very clearly. Like the same question can be posed for an equilateral triangle. You can just see it, that you can make the question, like it's possible for this question to be asked in the case of an equilateral triangle. That's all you need to know, that it is possible to ask the question in that case. And then since we know the answer doesn't depend on the triangle because it says maybe one answer or just find fill in the blanks, something like that, if that's told to you explicitly, something like that, then you can take this and work, because the question can be asked for an equilateral triangle, because there is a case where it can be an equilateral triangle. Okay, so this question can be asked for an equilateral triangle, that's why it does not. Now the question is, can this question be asked for a triangle where AD and BF are perpendicular? Okay. That is the question. If you can answer this yes, then it means it will not affect. Right? So can this, I'm just asking, can BF and AD be perpendicular with other things remaining same? Other these things remaining same. Can BF and AD be made perpendicular while keeping other information same? Other given information. Obviously, angles and all will change. We are changing the angle, but what we're interested in, that does not change. Does not change. Can they be made perpendicular? So right now, if they are not perpendicular, let's say they are like this, some angle, can you make them perpendicular? Yeah, so the question is, can you make them perpendicular without changing the ratio? Area is a very loose thing. That's what, if anything, we have learned that so far. Area is a loose thing. Let me give a small, because this is not such a very significant question, but these are the small things that add up. If I just give you this thing, which is parallel to the base, this is auxiliary thing to think of, just a ceiling here. Can you use this? So can we use that as a leverage to reason that you can go to a case when AD and BF are perpendicular and the other information has not changed? Can I move the triangle, do something with it so that the other information doesn't change, but the lines become perpendicular? You mean like increase or decrease the length of the sides? Um, yeah, so that maybe can be, I think that can be done, right? You can just do lift the size, but that is not very, maybe that's not very, yeah. No, it's logical. What I was trying to say is not very transparent, right? It's not very, not straight away obvious to explain. Like I can feel it that yes, it's possible, but yeah, or maybe you can just create an example, but a very straightforward way, and which is the archetype, you could say, the main thing of area not changing is to move the A on the ceiling. Just move the A on the ceiling, right? Just move the A somewhere here, here. You will be able to make the thing perpendicular. Is that right? Yeah. And that's a very straightforward way, right? Like that's just clear cut. You can't say that's not correct. Yeah. So and like it will not happen, right? Because we surely happen, and that is the canonical way. That's the most natural way in which area doesn't change, and we are only using that much and nothing else. So this already looks perpendicular. Maybe that's how I got the idea. But I'm just saying you can make it any angle. You can make it any angle of your choice because the area will not change and nothing else will change also. You see, and that's important for us to check. I'm not, yeah, have I made some mistake? We have to check. Actually, I may have made some mistake here, so we have to check. So, um, yeah, we have to. No, but no, this can be done, right? Or, or no. Let's see. No, no, no. So I am making a mistake. Do you see what the mistake is? Let me draw a better picture, okay? Because this picture already looks perpendicular. So let me change it. Let me draw something that doesn't. So I'm saying something that was wrong, I think. Yeah, I just realized it. So maybe if I take this, so just give me 1 second. Just want to make it clear. Let me make this 4:1. Then it looks correct. Now the question is, see, let me also we have to also change this. E, and this is T. So you see BD to DC is 4:1 and that's 3:2. Now the question is, can we make this perpendicular without changing the ratio, right? And I was saying that you can move A, right? But there is a slight problem with moving A. If you move A, then what can go wrong? Like if you move A and don't want to change the D, but then the location of F will change, right? That is a problem. So what I was saying is not correct. Okay. Yeah. Just to show it clearly, you can take like a perpendicular would be, I don't know, maybe somewhere here. No, that's not there. Maybe, yeah, now this time it's falling on F. This is strange. BF. Yeah, because the F will change. Yeah, right. Because if you want to keep F to be, so if you make this, then because if you take, like if you say no, I'll take the same like this F, then this F, this will not be 3:2, right? It will kind of change. Yeah, something will happen, but it will change. It will not remain the same. So that is the problem, and it will not remain the same because this is not parallel. Okay. So yeah, so this technique is, so my technique is wrong. Okay. So I think we have to go back to, so Ishana you were saying that you can adjust the length, right? I think that's the way. I think that can be made to work. Let me try to make it logical. Okay. So it just sorry, change this. Let's just bring it to original thing. Yeah. So what I was thinking is you could start with two perpendicular lines, Right. You could start with two perpendicular lines, AD and BF. So this we're just doing to reason, right? To reason that there is a case, or there is a triangle which can be done. Okay. You can start with this, and then you can try to make a triangle. So you can try to make it, and you see now it looks like it can be done. So you can make sure that this is 3:2, and then you stop here. Okay. And yeah, and then you just make sure that this is, and this can be done, I think. Oh, I'm just saying, I think, but that doesn't look correct. So this is a bit of a mess. 1 minute, so this is not a problem. So let's say you just join this, okay? Just join this. Okay. Now the problem is that when the D comes here, right? And this is the F, and this is the E, and this is the A and the B. Now the point is that the BD is to DC may not be 1:4. Okay. So how do you make it 1:4? Well, that is not difficult. You can just now move B on this, on A, on this line, on this red line. Okay. So if you move the B on this red line, then you can adjust the ratio BD to DC. Does that make sense? Right? Yeah. If you move the B here, then you see the ratio kind of gets more skewed. It kind of becomes more extreme, and you can understand. If you move it here, then it becomes less extreme, becomes more equalish, and so you can understand, right? So in this way, you can do it because you can prove that the ratio can be made anything, kind of, right? Because you can see it can be made very, very small, and you can also kind of reason it can be made very, very big, and it's a continuous thing. It can be made anything in. Okay, so we are just playing around with areas and kind of. So the answer is yes, but the reason is a little. So I just started with this perpendicular because it's like, okay, that's the goal. So let's start with that. Okay. Okay. So it can be assumed. So let us assume it for a moment and see if that makes the question easier, because this is a good thing that we have done, good specializations. I just started with simple things like moving the point E and so on, but then I think these ideas that I've developed is very nice. Let's see. So if it is perpendicular, then how does it help us? Does it help us? That is the question. And now I think we can't assume anything more. Yeah. So just for the sake of the answer, we are doing this. Eventually, you have to prove this. That the answer doesn't depend on the triangle, or do it in a way that doesn't assume anything. Yeah, but let's do this now and see. No, but BF and AD may not be same. And that, can you assume that? You have to go back to the diagram and check. What do you think? Let me write it. Yeah, can we assume? This is like we're doing it in a very strange way, but it is good. It's something new. Can we assume that BF is equal to AD? What do you think? Can this be done in the construction when we were doing? Maybe it can be done. Maybe, or maybe not. I don't. Yeah, maybe by adjusting this angle also, right? Right, it can be done. It seems like that. So think and try this. So try to make such a case. I mean, you don't have to explicitly give, you can just give it by that physical reasoning that you were doing, right? So this is a homework that you all, both of you should try, that make a triangle in which this BF is equal to AD and BF is perpendicular to AD, and this is the ratio. See if you can make this such a triangle, because then the question becomes very simple, apparently. Okay? So how does it become simple? If we assume that BF is equal to AD, okay, then AC and BC are also coming as equal. Why? Uh, BFC plus, right. Right. Okay, so you are getting this. Yeah. Then okay, then what's the next thing? So assume that they are the same. Mm. Yes, yeah. So assuming that the calculation is correct. Uh, mm-hmm, mm-hmm, mm-hmm. Yeah. No. That's right. But then will it help you to find this thing in the end? That is the big question. Right. You see, this thing is a little different, right? It's inside this. Yeah. Yes. But how? But how do you find, like, basically, see, in the end, at the end of the day, you have to somehow find this length AE, right? Or this, yeah, right. So you can try to use Pythagoras theorem. You can assume some lengths and so do the calculations. Do the calculations. So when I mean do the calculations, I mean try to find AE, like assume that this is 5x is something, you can even take it to be a number, it doesn't really matter, right? And then maybe you can try to apply Pythagoras, some variables, see. But it becomes very computational and not so interesting. Okay. Yeah, but these assumptions are nice. But see, let's try to see if you can, if we can, you can complete by this method. But let's come to the actual, thing, because see, in the end we are realizing that no matter how many assumptions you make, in the end what you need to figure out, okay, is AE by ED. This is the burning question, this is the main thing, right? Either that, or you can even find well, that's the most obvious thing, right? To find this AE by ED, you see, because if you have to find the area of BED, then it means that you would know AE by BD, right? Because that ratio, because BED, if you know, and ABD, then you can find the ratios and you can find the base ratios. And if you know the base ratios, then you can find these two areas, BED and AB. So these are the same questions, right? And you cannot avoid finding this. And this ratio also will not change because the ratio of BED will not change. So you can't assume AE is equal to ED. That's obvious because that will be the answer. Then the answer will be 1, but that's not the case. So we cannot assume it, and also you can try to see that you cannot assume it. If you try to do it, try to assume it and make a case. So anyways, this is the key thing to find. Even if you, in the end, I get it as isosceles, the ratio is still you need to find. So we will find the ratio without finding any of the lengths. And that will be the key thing. That will be the good solution, right? We will try to find AE by ED without finding the ratio. Okay. So my first question again to all of you is it clear why we are trying to find AE by ED? That's the key thing that one has to understand. Okay, so hold on. Yeah. So now that it is clear that we need to find this, now we can go ahead and try to find it. Okay. So how do we find this ratio? Now, this is a technique which you may not have done. So this is very different technique maybe. But this is again a very fundamental technique. So we have seen that areas come from these ratios. You have to find ratios to find the areas, right? Or vice versa. It's also used. So the way I will find this ratio is by projecting the ratio to a more familiar place. Okay. See, the way we find ratios is by comparing it with other similar triangles and so on, right? So if you want to find the ratio AE by ED, I will project the ratio on AC, meaning I will draw a line which is parallel. And you know what this is parallel. This is parallel to EF. So is it clear why I'm doing this? Okay. Because this AE by ED will now be equal to AF by FG. And that's in a more familiar place, right? I've taken, it is not, no, it is not congruency, it is similarity. Right. And so yeah, first check this. Is it clear that this is the correct thing to do? This is correct. Check. Okay. So you can just say if you want to prove it, like if you want to use similarity rules, and you can say like AEF is similar to ADG, right? Yeah, because I've not discussed similarity, so that's why. Unab, you also know this. You know this, right? Means you remember this because you would have studied this, right? Yeah. So AEF is similar to ADG, and then that means that obviously, yeah, you can say AE by AD is equal to AF by FG, and then from there again you can do calculations and you will get this. And it's also very obvious, sort of, right? Because you're kind of letting everything complete up to A, and it's becoming. So I had a question I wanted to discuss. Right, I will ask that in the end. Yeah. So there are questions coming up in the end for you guys related to what we have done. Some conceptual, some just problems. So for now, this we have. Okay. So this is fine. Now, so it is equal. That's the first thing. That is just a rule, and it's also very clear geometrically. But is the idea clear? Why I am doing this? Why I am taking this line parallel to BF or EF? Why I'm drawing this point G on AC? Right? Okay, that should be clear, because then only you can extend the idea to more difficult places, because this is a simple example. Okay, so now, yeah, now what do we do? That is the question. So I'm just writing these things here. And now you guys can think what to do now. No, it's completely, yes. Mhm. Put the values, which values? Mm-hmm. Okay, we can take it as h. Mm-hmm. No, 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 no. Why? What is h here? That is not the AE by ED is h. Uh, no, no, no. It's not height. It's not perpendicular, right? And maybe there will be a case where you can assume that also, but yeah, that may actually simplify the question. Okay, taking this as the perpendicular, right? But I don't think it will. In the end, you will have to find this ratio is will still remain a question mark, right? So do we get this intuition, right? Do all of us get this intuition, right? That if you simplify the question, it doesn't really simplify. Right? This ratio has to be found. Right? This ratio does not simplify, right? Because this is the answer. So that is the catch. Something hard has to be done in somewhere. Okay. So you see, now you can just focus on the triangle BFC. We missed this, right? If you focus on this, then FG by GC, you can find what is FG by GC. Mm-hmm. Yes, it's same as BD by DC, right? Now we're just looking from this angle, this triangle, and this parallel line. So you see, it's always a part of two, and that is the power of this technique. That's how it works, right? And so it's just 1:4, and so you have to divide 2y into 5 parts, right? So now you can find FG, right? So you can do the calculations, and you can find FG in terms of y. Okay, what will it come out to be? Uh, I don't know, one fifth of two something something, right? Yeah. So basically, find FG in terms of y. In terms, or let us just quickly find it, right? Why am I? Same takes the same time to write all this. So, yeah, you can just find it. So you can do this, and this is 4, and you can add a 1. You can do this in any way. You get 2y, you get FG, you get 5, right? So FG is 2y by 5, right? You can find this in any way. So this is 2y by 5, and this is 3y. So now you can find the ratio. Okay, so it's 15 by 2. Just calculations. Okay, so this is the very simple method of just drawing the parallel lines and just coming down to deciding what ratio I need to find, and just coming down to that and drawing the parallel lines, using it, and then moving forward. Okay. So let us stop here. I will just give some problems now so that it's there in context. So I'll just give a few conceptual problems and some. So this is just an extension of what we did today. So it's kind of I had taken one triangle like this, and the other triangle I had kind of kept as degenerate. Right, this triangle. So there was this triangle, right? But now I will move the head of this triangle also. So I will try to, no, I will move it in the other way maybe. Right, then it becomes more interesting. Oh, it's gone. 1 second. What I was saying is, uh, 1 minute. So I'm just doing the same mistake over and over. Just moving it somewhere. You're getting the intuition through these things how malleable area is, how much you can work it around. So this is ABCD. Yeah, let me not make a very concrete question. Let me keep it as CDEF. So let's say if this was 1, this was 2, and this was 4. And this is 3. Then find the rest. Okay, find, wait, 1 second. Huh? I should have prepared the question. 1 minute. Yeah, that is supposed to be that was supposed to be the area. Okay, but no, let me change the question. Okay, because I'm not. If it's not an interesting question, then it will not be good. Because some questions have to be like questions that you can solve and interestingly. So I'm just kind of copying a question. So just give me a minute. Yeah. I mean, after some time, when you understand the nature of these things, then you can make questions on your own and just try to solve them. And you will also know if it is solvable or not, because you will have the intuition, whether area is, whether there's a unique area or not, and so on. So this is the problem. And then this area, so the area of this thing is, let's say, 5. Okay. And so the area of this thing is, let's say, 2. So this is here. No, I mean, if this is 5, then this shouldn't be 2, right? It should be 1. Not even 1, but yeah, let's keep it 1. Okay. And the area of, so I'm just going to draw some areas. This thing is quadrilateral, right? This thing is, let's say, 3. Okay, the 3 is visible. And this is 1. Okay. Then I want you to find the area of this small piece here. And this is not as difficult as it looks. Okay, note it down. None of the ratios are given. So it's easier. Find it maybe by a bad method or good method, but find it and then try to find it by proper way. Okay, so note it down. I think you can understand the question. So yeah, so first the question is not clear. So that I should sure. So the shaded regions area is given. None of the ratios or anything are given about F, or if I to call this G. Okay, you have to find the area of the red part. That is the unknown. So this is a question mark. Okay, is the question clear? Okay, so then it's good. Now let's quickly move to the other question. So here is a question. Find area of a triangle with sides 12, 10, and 13. Okay, and then find area of a quadrilateral with sides 12, 10, 13, 13. Okay, so for the triangle you probably already know is the Heron's formula. For the quadrilateral, you have to think. It's a conceptual question. It's not just a calculation question. Okay. So you have to think. So these two questions. And yeah, let me just give a similar question to what we did today. Sorry, there is some noise. Yeah, never mind. I think just see just 2 minutes. Just finish this. Now we have this, and let's see. Then I am just giving some lines. This time it's just an extension that you can just make for yourself. But I'm just giving this because this has a simple, simple solution. So you see, you can assume just for simplicity, because you can also use some symmetry reasoning. Sorry. So that's why I'm going to give some simple numbers. So AD is equal to DC, because it may, you may form some good reasoning through that also. Otherwise, the method that we've discussed, those will be the main ideas maybe. So yeah, given this, you can find something, anything, find this blue region, maybe. Or you can just find the base thing on it. That's same thing, doesn't matter. Find this. You can note that. You have to remind me the questions next time, or I think I've just saved them also. One more question, maybe. This is a classical application. So that I'm asking. This you will find everywhere in books and on the internet, this exact thing. But try this yourself first. You can see. I mean, even if you find a solution somewhere, you should present it in your own way in the end. But first try it. So we all know the Pythagoras theorem, right? But if you don't understand numbers, if you only understand areas, then what does the Pythagoras theorem say in terms of areas, right? It just says that if you have I forgot, I cannot make a diagonal square. Yeah, so the Pythagoras theorem only says that if you erect squares on the sides, right? Then then this square, one second now. It's a square, just assume. This, sorry. So this square and this square. So you know what to prove. Yeah, that the sum of the areas of these two squares is the area of the square on the hypotenuse, and that's the Pythagoras theorem, right? But I want you to prove this thing without using the Pythagoras theorem, obviously. So yeah, so you know what to prove, and just write it, label it if you want, and try to prove. So try to prove that this is there. To prove that A plus B is C. Okay. So yes, ABC has squares. Yeah, because you see that's what the Pythagoras theorem says, right? If you see it in this way, and yeah, and the way to just for the hint, otherwise it's hard to get started, maybe, is to draw these lines. Maybe this line and this line, and from there do some reasoning on areas and so on. So you have to prove that the area of A plus B is equal to area of C. How you will do it? You have to draw some lines like this. Okay, so yeah, you have to think. This may be a little hard, but this is a classical thing. So okay, so if you've noted all the problems, and if there are any questions, then you can ask. Otherwise, we are done. Try these problems. Try the problems I gave yesterday. I will put the video if phone up, and then you can try all these problems. for yesterday also. Okay then. No, I didn't discuss anything related to that yet. There was that thing was I was saying for some other thing. I don't remember now. So yeah, but that was relevant because yeah, because I will be doing similar stuff, but I usually will do it in a different way. So it's good if you just watch that also, and so when I do it in a different way, it will be yeah.